Have you ever come across a piece of science communication that's just so simple, so clever, you have to stop and, well, just admire it? Today, we're doing exactly that. We're going to break down a truly brilliant way of explaining one of the most complex molecules in biology, DNA. Let's see how it's done. It all kicks off with this amazing hook. Twist, connect, munch, build DNA you can actually eat. Right away, it's active, it's intriguing, and it makes you think, wait, how? This single line is just the perfect doorway into a really complex topic, and it comes from a pretty cool source. Yep, this whole genius idea comes from a script for an animated video for kids. See, the goal wasn't to write some boring textbook chapter. It was all about creating a joyful, hands-on experience for a young audience, basically turning a science lesson into a super fun family activity. So, to be clear, we're not actually making any candy DNA today. Instead, we're going to go a little meta. We're going to deconstruct the strategy itself to really understand the educational psychology that makes this whole suite approach so incredibly effective. Okay, first up, a recipe for engagement. This is all about the foundation, how the script makes sure that kids aren't just watching, but are totally and completely hooked from the get-go. What's amazing is how specific the source script is. It's not just for kids, it's for 6 to 12-year-olds. The tone isn't just happy, it's joyful and yummy. I mean, the script even calls for the sounds of crunches and laughs. Every single piece is meticulously crafted to build this multisensory, shareable experience that feels way less like a lesson and way more like just pure fun. And check out the language itself. Every word is active. It's empowering. You're not just a student, you're a candy coder. You're not just learning something, you're gonna Helix. Every single phrase is designed to be a call to action, creating this really cool identity and a memorable experience. That is just brilliant. So let's see how this all builds, literally. Section 2 is about building the lesson itself. And this is where the script so cleverly embeds real scientific principles right into a simple, hands-on project. The whole process starts exactly where it should, with the foundation. Before they get into any of the complicated bits, the script has the kids build the backbone of the DNA molecule. This gives them a basic ladder frame and a real, tangible structure to work with. The instruction is so simple, isn't it? But it's a clear, physical action. By twisting two Twizzlers together, a kid is physically creating a model of the sugar-phosphate backbone, making this totally abstract biological component feel solid and real right in their hands. Okay, so once that frame is built, the lesson introduces the next crucial layer, the base pairs. This is where the fundamental rules of DNA get introduced, but not as some boring list of facts, as the very next step in the building process. And right here, this is the core of the whole lesson. A fundamental law of genetics that adenine always pairs with thymine and guanine with cytosine is transformed into a simple, intuitive color matching game. Red always goes with yellow. It is such an elegant way to teach a non-negotiable scientific rule. This quote from the script really just captures the whole mission, doesn't it? The model isn't just a fun craft. It's designed to be scientifically accurate in its core principles. The deliciousness? Well, that's just the Trojan horse that carries all the knowledge inside. So how does the script actually make that crucial connection? How does it make sure kids don't just see a candy ladder, but they actually understand the DNA it represents? This next section, the Sweet Why Explained, is all about bridging that gap. You know, the technique at play here actually has a name. It's called metaphorical simplification, and it's one of the most powerful tools in education, period. You take something totally abstract and invisible, like a molecule, and you compare it to something simple and concrete, like candy, making it instantly understandable. And here it is, the masterstroke, the perfect one-to-one mapping of the metaphor. The Twizzlers aren't just licorice. In this lesson, they are the sugar-phosphate backbone. The colored marshmallows aren't just snacks, they are the base pairs. This direct comparison is what cements the learning and makes this whole thing such a powerful educational tool. But, you know, the lesson doesn't just stop when the model is built. A truly great educational experience opens the door to more questions, and this script does exactly that. It encourages deeper engagement long after the main activity is over. The script calls these pro-candy twists, and they're basically awesome extension activities. Like, what's a gene? Oh, it's just a longer helix. What are phosphates? Well, let's add some jelly beans. These suggestions are so clever because they scale the lesson up, showing how this simple model can be a gateway to way more complex ideas, all while keeping it fun and collaborative. So, what's the big takeaway from all this? It's that learning isn't just a mental exercise. When you engage multiple senses, the sight of that colorful model, the touch of actually building it, and yeah, even the taste of eating it, the lesson gets deeply embedded. It becomes way more memorable than just reading about it in a book. And that leaves us with a final thought. This technique is just so powerful and so versatile. So I'll leave you with this question. If you had to explain another complex idea, I don't know, plate tectonics, the solar system, a computer algorithm, what food would you use to make it simple, fun, and totally unforgettable?